Work rate problem. Okay, is our topic today. Okay, now there are two things you gotta remember for this work rate problem. Then you're done. Really, this is a part. Once you know this, you're done. Okay. First thing, whenever we have work rate problem, it is very similar to the formula that involves rate. Rate times time equals to what? Distance. But instead of that, we have work rate times time equals to not distance but work done. Is that okay? Is the first thing you gotta remember. So I'm gonna write it in short. Rate. I'm gonna just write rate for work rate. Okay, work rate times time. Guess what that time represents? If I'm talking about work, how much time you spend doing the work, and the W represents the work done. Okay. That's what you have to remember. So write that down on the top somewhere on the work rate problem, because that's the formula you're going to need. Rate times time equals to W. Instead of distance, it's work done. Secondly, another thing you have to remember is they're not going to give you a work rate. So you have to figure out the rate. Now, looking at the formula, how do you solve for rate? How do you get the R by itself? Divide both sides by what? T. So the rate, write this down. This is the second thing you need to know. Rate equals to the work done over time. So on these problems, they're not going to give you the work rate. You have to figure out the work rate. Okay, it's the work done over time. So these are the two formulas you're going to mainly need for this work rate problems. Actually, one other thing you gotta remember is, let me show you, hold on. So there is actually one more other thing you gotta remember for this. When we talk about work done, okay, let's say somebody did this work. Well, maybe they were painting the house, right? They finished the work. How would you represent work done? Well, if you finished all your work, it means you done 100% of your job, right? Whatever you need to do. Now, what does 100% mean in as a number? One. So please remember, this is another thing you gotta remember. Work done, when they say they finished the work, that means what? The work done is 100%. Okay. What if they only done half of the work? What would that be as? 50%. What's 50% as a number? 0.5, which is 1 over 2. 1 over, not 5, 1 over 2. Right, guys? Does that make sense? So work done is represented as percent. Okay, as percent. So keep that in mind. Work done is represented as how many percent of the work is done. If you finish all the work, which is work done, right? You finish the work, that means it's 100%, it represents 1. Okay? Does this make sense? So knowing all these things, work rate times time equals to work done. The rate, of course, to represent rate, is how much work you finish, right? That'll be in terms of percent, right? As a number over time. Okay. So does this make sense? Yes? All right. Let's look at our first example. Okay, so before I do our first example, let me just ask you a very simple question. Knowing what we know from up here, we know that work, rate times time equals work done. Rate is work over time. Now, and work done is 100%, right? If you finish all the work, it means 1, really, right? But that's how we represent. So if I ask you this, now I'm not asking for anything else but work rate. It says, I can finish all my homework in 2 hours. What is my work rate? So how would you figure out the work rate? Now, it says I can finish all my homework. So what is my work done? If I says all my homework, it is? Yes, Kira? No. It says I can finish all my work in 2 hours. Okay, so it says I finish all my work in 2 hours.
Yeah, that's what she's saying. She's saying the rate is 50%.
Oh, okay. So rate. Okay, I see. All right, so well, let's answer this question first, Kira. If I said I can finish all my work, how much of work have I done? How many percent? 100%, which means what does 100% mean in terms of a number? 1. Would you all agree? So I'm going to start with that. Remember, from what's work rate equals to work rate equals to what? Look at on top. Well, we started off with the rate times time equals to work done, right?
Yeah.
So how do you figure out R by itself? R is W work done over time, right? So so we're looking for R, right? So what's R equal to? What do I plug in for W? That's what I mean, Kira. What goes on the top? Because we finished all the homework.
Plus, yeah.
1 is exactly right. Because we finished all the work. That means 100%. So we put 1 there. Okay. What about time? How long did it take us to do the whole thing? 2 hours. So your work rate is simply 1/2. Does this make sense?
Yeah.
So your work rate is 1/2. Now, what kind of unit are we writing this down in? What would the unit be? This is sort of interesting. It's not kilometers per hour, is it? What kind of work rate is this? If you had to put down the, it'll be work done, right? Per hour. That's kind of a very interesting unit, right? Right? Have you ever seen this kind of unit? We've seen kilometers per hour, right? Meters per second, things like that. We haven't seen work done per hour, but that's what it is for the work rate. Is that okay? So the work rate is 1/2, and it makes sense. Why? Because if you multiply, remember we started with this. If you multiply this work rate times 2, guess what? Your work done is. So if this is work rate, right, and if you work for 2 hours, how much work would you have finished? What's half times 2? 1. What does 1 mean? 100%. What if you only work for 1 hour? How much work would you have finished? Well, plug into the formula. Rate times time equals work done. 1/2 times 1. What's that? Half. How much work would you have finished if you only work for 1 hour? Half of the work. 50% of the work we've done. Do you see how the work rate works? Yes? What if you, okay, you could keep going and so forth. Do you see how you come? So easiest way to find the work rate is work done over time. And it's nice when work done is equal to what? 1, because it makes it so much easier, right? Because you don't have to simplify the fraction and so forth. Does that make sense? So let's look at our first example, okay? Here we go. Who would like to read this for us? How about, let me pick somebody at random. How about, hold on, it's loading. Okay, how about Ire?
You can shovel your driveway in 3 hours. Your friend Amy can shovel the driveway in 2 hours. How long will it take you and Amy to shovel your driveway working together?
So, alone, you can't shovel your driveway in 3 hours. So, what does that mean? By yourself, you could do all your job, 100% of your job in 3 hours. You could do it in 3 hours, right? Your friend Amy could do this in 2 hours. So who's a better worker at this? Amy. She could finish it in an earlier time. Okay. Now, here's the important part. What is the unknown in this case? Okay, rate is sort of unknown. You're right. We have to figure out the rate. But really, they're asking how long it will take you and Amy to shovel your driveway, right? Finish this job together. So, do you think it's going to be more than 2 hours?
No.
Do you think it's going to be less than 2 hours? Yes. Why? Because Amy, by herself, she could do the whole job, right, in 2 hours. So if I'm helping her, right, it should be less than 2 hours. Does that make sense? Okay, so now we have to come up with, and now what kind of, we're going to need this chart. Work rate times time equals to work done. Just like rate times time equals distance. Isn't that right? Do you see how it's very similar to what we've been doing with the stock and bond, right? The interest rate times amount you invested equals the interest, right? It's always kind of similar. Anyway, so here's me and Amy. Now, how am I going to figure out my work rate? So when I say my work rate, I mean my work rate when I work by myself. What would the work rate be? We just talked about this. Work rate, if you want to find the work rate, is work done over time, right? So how long does it take me to do the job by myself?
3 hours.
3 hours. So what would my work rate be? Because in 3 hours, I could do 100% of the job, right? Which means 1.
3/1.
Is it 3/1 or is it 1/3? It's 1/3, isn't it? Do you guys see what I'm trying to say here? The work rate for me will be 1/3 because, remember, we just talked about this. Rate is equal to what? Work done, which is in this case, is nice, right? It's really nice. It tells you that I could do the whole job by myself, which is 100% of the job, which is 1/t, which is 3. It's always going to be like this, okay? So it's work done over time. And many times they would tell you that work done is 100% done. So you could it'll be 1 over some time. Okay, what about for Amy? What would it be? They told us Amy could do the whole job, which is 100% of the job, which means 1. 1 over what? 2. So that's my work rate. So please keep that in mind. This is the important part. If you know how to figure out the work rate, boy, okay, then it should be simple. And we said let T be what? Time that, yes. Yeah, the time it takes both of them to finish, right? Does that make sense? So that's our unknown. So I'm going to put T for time for both of these, right? Because aren't they working together? Starting at the same time and then ending at the same time. And we know that this time is going to be less than 2 hours. It better be, right? Because Amy alone could do this whole job in 2 hours. Is that okay? Right? Now, so then how much of work have I done if I work T hours? What do? You multiply work rate times time, so it wouldn't just simply be T over 3, right? And the other is T over 2. And then here, let T be the time. It will take both. This is important. Both to finish the job, right? Does this make sense? And then, if it really does make sense, what will your equation be? One person, 2 people. I want you to discuss this to your group. If you really understood this, this is how much. By the way, what does this T over 3 represent? This is how much what? This is how much of the job I've finished, right?
Yeah.
What does T over 2 represent? That's how much of the job that
Amy.
Amy finished. So how can you come up with an equation? Go ahead, everybody think about this. What equation would you come up with this? I'll wait. All right, so it was really good that I heard some of you saying, why do we even need to look for time? Don't we know the time for myself and for Amy? Because I know for me it takes 3 hours. For Amy it takes 2 hours. We're done, right? Is that the time we're asking?
No.
No, we use those time to figure out the rate. What is it they're asking here? What's the difference? Because it sounds like they're asking something else, right? What is it? What is this time that they're asking? How is that different than like the time that it takes me to do the whole job by myself and how long it takes Amy? Because we know that time. What time are we asking here? Grace, how is this different? Yeah, this is when they work together, right? This is going to be the time when they work together. How long could they finish the whole job, right? Does that make sense, guys? Do you see the difference between the time? We're not asking how long it will take me to finish the job. We already know that, right? We use that to figure out our rate, right? We're asking how long would it take when they work together. So when they work together, how much job would they have done? How many percent of the job? 100% of the job. What does 100% mean? 1. What's your equation going to be? How about Justin? What would I say?
T over 3
Uh-huh.
T over 2.
Yeah, exactly right. Justin's got it right. When you add these together, it will equal 100% of the job done, which means 1. 100% means 1, right? So simply, if you add T over 3 plus T over 2, it should equal to 1. And we then need to figure out what T is. And don't we know how to solve a simple equation like this? Thank you. Don't we know how to solve a simple equation like this? All you have to do is multiply both sides by D, LCD, and it's easy to see what the LCD is. It's what? 6. Go ahead, everybody, multiply both sides by 6 and find time. Okay, I'll wait for you. So as you can see, when you multiply both sides by 6, on the left side, it simply becomes, what do I get? Yeah. Isn't that nice? Look. This whole equation becomes simply 2t plus 3t equals to 6. Very simple to solve, isn't that right? You add them together, you get 5t equals to 6. Of course, t comes out to 1 and 1/5. It's sort of nice in this case to write it as a mixed number because you kind of want to know what this will be in terms of time. Is this less than 2 hours?
Yes.
Yes, and it makes sense, right? It is less than 2 hours, right? Because Amy alone, she could do this the whole job by herself in 2 hours. It's better if I'm helping her. It should, right? It should help her. It should be less. Okay, so what does this mean? Well, we figure out the answer. It means it will take 1 and 1/5, which is 1 hour and 12 minutes, right? If you were to convert it into minutes, hours to finish the job together. That's the important part. Together. We're not asking, right, how long it'll take for one person to finish the job by themselves, because we already knew that, right? But we're asking how long it'll take if they work together. It's 1 and 1/5 hour. You don't have to convert it into minutes if you don't want to. I just wrote it down. Okay, is that okay?
Yes.
Yes. Let's move on to the next example. Okay. So let's go to example 3 because example 2, as I said before, is very similar to example 1. You could do that yourself. when we get a chance. Now, it says Jake can rake our lawn in 50 minutes, and I could do it in 40 minutes. Who's better at this job? I this time, right? Because no, Jake, it takes him 50 minutes, whereas it takes me 40 minutes, right?
Sorry.
If he rakes for 5 minutes before I join him, you see they kind of put a little spin on these sort of question. Okay, it's not like the one that we just did where they start at the same time, end at the same time. Here it says if he rakes 5 minutes before I join him. Okay, does this make sense? So he does for 5 minutes, and then I join him. It says how long would it take us to finish? Okay, so this time, what is the unknown in this case? Okay, one person see it. Okay, how about Rania? What's our unknown here? The time what? We have many times. We got 50 minutes, 40 minutes, 5 minutes. Which time are we talking about? To when you work together, right? So this is actually the time when I join him. That's when we finish, right? The time it takes us to finish together, right? You're right. It's just, do we count that 5 minutes that he's been working then? No, we don't add that. It's whenever I join from when we finish. Is that okay? So I'm going to say let T be how long it'll take both to finish. Oops, I don't know why it does that. Okay, so let T be how long it'll take both to finish. Is that okay? All right, now look at all the units in time. Everything's in terms of minutes. Do we need to convert them into hours and so forth? No, you don't need to. For these work rate problems, you just have to have the same unit throughout. It could be minutes, seconds, hours, doesn't matter. It's not like, kilometers per hour. It's not, they haven't given you that rate. So you could use just the minutes. Now, here is the problem then. So we got let T be how long it will take both to finish. So what are you going to write down for, so there's work rate for Jake. This is, again, Jake could do the whole job, which is 100% of the job, which means 1. In 50 minutes, what is going to be our work rate? It's going to be very similar to last time. Everybody think about this. Go ahead and fill it out. And can you guys all fill out the work rate for yourself? I'll wait. Everybody, go ahead. Try it. I'll wait. Okay, this is important. So as I said before, you don't have to convert them into hours or anything like that, okay? Because this is work rate, right? But you have to keep everything in terms of same units, right? Everything's in minutes, you're good. What is going to be the work rate for Jake? How about Zareth? Since Jake could do the whole job in 50 minutes, which means 100% of the job in 50 minutes, how do we find the rate? 1 over 50. How many people agree with Zareth? How many people have different answer for that? Okay. How many people are not so sure? Okay. Remember work rate? Go back to the very first thing I talked about. Rate equals to what? W over T. What is the W in this case?
Work done.
Work done, which is 100%, right? Because he could do the whole job in 50 minutes. So what's going to be the W? What will the W be? 1. Over how long does it take him to do the whole job? 50 minutes. So it is 1 over 50. So Zareth is correct. It is 1 over 50. Right, guys? Remember we talked about this. Rate is equal to, if you don't believe me, right? Remember rate times time equals work done. Divide both sides by T. You get R equals to W over T. What's W here? 1. Because you do the whole 100% of the job. You finish it. 1 over, how long does it take him to finish the whole job? 50 minutes. Is that okay? What about then the work rate for yourself? How about Allison, Kim? What do you think? 1 over 40 is correct. Guys, please keep this in mind, okay? Can I write 40 there or something like that? No, you don't want to do that, okay? Work rate is going to be, you will see that work rate is always going to be 1 over something, because, when you simplify this fraction, even if they don't give you the 100% of the work done, you could simplify this fraction. You want the 1 over something. Basically, you want to know how long it would take him to do the whole job, right? So which is 1 over how long it takes him to finish the whole job. All right, so then, what's the time for Jake? Now be careful, it says, if he rakes for 5 minutes before I join him. So, who's been working longer in this problem? Jake or me? Jake, how long more did he work? 5 minutes. So what are we going to put down for time? How about Noor?
You're gonna put for Jake. You're gonna put T plus 5.
T plus 5 is correct. Okay, so this will be T plus 5.
And for me?
Yeah, for me it will be?
T.
Just T. Because I joined him, right? Because he's been working before me 5 minutes. So I need to add that to the time because he's been working there more than I did. Okay, now For what is then the work done for Jake? Well, simply you
1 over
multiply the work rate times time. So you multiply these together. That's how much of the work Jake did by himself. And this is how much of the work that I did by myself in this given time. Does this make sense? And of course, did we finish the whole job? Guys, did we finish the whole job? Is that what we want to find out? Yeah, it says how long will it take us to finish? When they say finish means 100%, right? 100% finish. What is the equation going to be? Who could tell me? Angie, what would our equation be?
T plus 5 over 50 equals
1 equals 1 is exactly right. You basically add how much work Jake did plus how much work I did. You should equal to 100% of the work, which is 1. Oops, you don't see 1 there. Okay? All right, now, is this pretty simple to solve? Yeah, once you multiply both sides by D, again, LCD. What's our LCD for 50 and 40? Yes, 200. Multiply both sides by 200. Go ahead, everybody finish? I'll wait. Okay. So when you multiply both sides by 200, okay, somebody tell me what we get on the left side. How about Stephanie? What do I get on the left side?
4, I get 8 times T plus 5 plus 5 times.
Good. Do I need to multiply this 200 to T plus 5? Do I need to distribute it there? No, you're multiplying 3 things, aren't you? How do you multiply 3 things, guys? You're multiplying 200, 1/5, and then this binomial. How do you multiply 3 things? You multiply 2 at a time. You just multiply 200 times 1/5 and it becomes 4. Then you distribute that 4. Does that make sense? Don't multiply 200 inside the T plus 5, right? That'd be wrong. Again, here, you're multiplying 200 with 1 over 40 times T. You're multiplying 3 things. You multiply 2 things at a time, right? So 200 times 1 over 40 is 5, so you get 5T. And of course, on the right side, don't forget, right? On the right side, you get 200, right? 1 times 200. And of course, then you distribute this 4, you get 4T plus 20 plus 5T equals to 200. Then you gather your T's. 4T plus 5T, class, what's that? 90 plus 20 equals to 200. And I subtracted 20 from both sides, so you get 180. How many people got T equals to 20? Very good. What does this represent? Audrey, what have we found? What does this mean? T equals to 20.
How long will it take us to finish?
Yeah, this is a time. This is a time. It will take 20 minutes for both to finish, right? So how long did Jake work? 25 minutes, because remember he was working, right? Before me, 5 minutes, right? Then I joined him, right? So the time that we worked together was 20 minutes, even though Jake worked 25 minutes and I worked 20 minutes. Is that okay? All right, let's look at the last one then, okay? All right, let's look at number 4. It says, Phil can paint the garage in 12 hours. What's the rate for Phil? 1 over 12. It's always going to be 1 over that time it takes him to finish the job. Is that okay? You should be all aware. Okay, and Rick can do it in 10 hours. So what's the work rate for Rick? 1 over 10. Does that make sense? Because Rick does 100% of the job in 10 hours. It's 1 over 10. They work together for 3 hours. Okay. How long would it take Rick to finish the job alone? Okay. So this is kind of interesting because it says Phil can paint the garage in 12 hours and Rick can do it in 10 hours. They work together for 3 hours. It says, how long will it take Rick to finish the job alone? What does this mean? Don't we know already Rick's time to finish? It says Rick could do it in 10 hours. Right? What is this asking? How long would it take Rick to finish the job alone? Yes?
So if we work together for 3 hours,
Hmm?
then Phil needs
Exactly. They work for 3 hours. Does that mean they're done painting the whole job, whole house? No. Okay, they're saying, so I guess Phil has to go home or something. And then afterwards, how long would it take him to finish, Rick to finish the whole job by himself? Do you see what it's asking?
Yeah.
Okay. Do you understand what's going on here? We know the work rate for Phil is 1 over 20. 1 over 12. We know the work rate for Rick is 1 over 10. Now they work for 3 hours. This time they're not done painting this whole house.
It's 8:50.
So we have to figure out how much of the work that they finish in 3 hours. Does that make sense?
Yeah.
So we're gonna let X to be what? TB. The time for Rick to finish the rest of the work. So Kira is correct. It means that Phil left. Okay. Right? And now Rick has to, maybe this is Rick's house, right? Rick has to finish the job by himself. So write that down. Okay. So let's fill out the chart. It's going to be always similar as before. Work rate times exactly same. I mean, not similar. Work rate times time equals work done. What's the work rate for Phil again? It was 1/12, and the Rick was. Who's best at this? Phil or Rick? Rick is better. So it's kind of good that Rick, he has to finish the job by himself. He's faster. How long did Phil work, by the way? 3 hours, right? Right? Because he left after 3 hours. What about Rick? How long does he have to work? Would it be T minus 3? Because they both work for 3 hours. Now Rick has to work more to finish the job by himself. Yes? 3 plus T would be the time for Rick. Isn't that right? Oops. Because he has to finish the job by himself after Rick leaves. Because Phil and Rick, they work together for 3 hours. Phil goes home. Rick has to finish the job. So whatever the job that's left over, Rick has to finish. So that's the time that we're looking for.
What if you did T equals like the whole time Rick did it alone? So you put the T minus 3. Never mind.
I see what you mean. If you let T be the time it took, that gets too complicated. Just leave it. But does this make sense though? Right? Phil and Rick, they work together for 3 hours. Now, Rick has to work more hours. We have to figure out what that time is. I think this is less straightforward. Okay, now, what is then the work done by Phil? 3 times 1/12, which is 1/4. And then, of course, Rick is 1/10 times 3 plus T. Does this make sense? Okay. Yes? So, here we go. So, when we do this, now, do you see how this is? Oh, thank you. Do you see how this works out like this? What is our equation going to be then? Okay, how about Cole?
1/4
Uh-huh.
is 1/10 times 3 plus T
Uh-huh.
equals 1.
It goes 1. When you add them together, right? They have to finish the whole job, right? Does that make sense? Because Rick works more hours, right? Phil did basically how much work is Rick going to do? If Phil did 1/4 of the job, he has to do 3/4 of the job, right? Anyway, so when you add them all together, it equals to 1, right? Do we know how to solve this? What is our LCD, class? 20, isn't that right? Go ahead, multiply both sides by 20. Finish it up. I'll wait for you. All right, so when you multiply both sides by 20, did you all get 5 plus, right? 2 times 3 plus T equals 20. Did you all get that? How many people got this? Raise your hand. Thank you. All right, then you distribute that 2, and you should have gotten 5 plus 6 plus 2T equals 20, right? And then you gather your like terms, 17, right? 5 plus 6, I mean not 11, not 17, 11, 5 plus 6, 11, plus 2T equals 20. You subtract both sides by 11, you get 9. How many people got T equals to 9/2? Very good, which means 4.5 hours, right? So after Phil goes home, Rick has to do 4.5 hours of work. Is that okay? Does this make sense, guys? Now, does this mean that Rick only did 4.5 hours, or do you have to add 3 hours to this? How long did Rick really do his work? Yeah, 7.5 hours, isn't that right? Because you gotta add 3 hours to this, right? So this is only time when the job that he did by himself after Phil left. Would that be okay? Is that okay? Good. All right. Good. So in this case, they're only asking, after Phil left, how long did he work? So which is what? 4.5 hours. Okay. Can you do something like this for your homework tonight? Do you you all get this? All right. Good.